Video 4, Chapters 9 through 11, Basic Problem, Constructing Confidence Intervals. So for this problem, we're given the problem. Researchers studying iron deficiency in infants examined infants who were following different feeding patterns. One group of 26 infants was being breastfed. At 6 months of age, these children had mean hemoglobin levels of 12.9 grams per 100 milliliters of blood with a standard deviation of 1.6 grams per 100 milliliters of blood. And we're going to give a 90% confidence interval. So we're going to do PANTS. So for P, parameter of interest, is the mean hemoglobin level of breastfed babies. For the assumptions, which is A, we have randomness is not stated, but we should always assume randomness unless otherwise stated. Normality can't be assumed based on the central limit theorem because the sample size is only 26. It's not big enough to say that it's normal, but we should always proceed with caution. For N, it's going to be a T interval confidence. So for the T, and that's going to be our test, you have mean plus or minus T star. That's going to be found on our T chart for a 90% confidence interval. Standard deviation over square root of N. So for the confidence interval, we're going to put 12.9 because that was our mean, plus or minus 1.645 found for the 90% confidence interval on the T-score chart. Then we have 1.6 for the standard deviation over the square root of 26, which is the number of babies that they had, and we get the two numbers, 12.3838 and 13.416. So S, statement and context. We are 90% confident that the true mean of hemoglobin levels of breastfed babies is between 12.3838 grams per 100 milliliters of blood and 13.416 grams per 100 milliliters of blood.